Please welcome Mr. Dennis Muilenburg.
Welcome to my house, baby, take control now. We can't even slow down. We don't have to go a while. Welcome to my house.
All right, well, good morning. All right, I wanted to make sure you guys are ready to go. Well, I'd like to talk with you this morning about an important topic that I think fits with a number of other categories you've been discussing during the meeting this week, and that is the future of mobility. And there is more innovation happening in the aerospace arena today than I can remember in my 34 years with the Boeing company. And this exciting time of innovation as it moves into future mobility and unmanned aircraft and unmanned vehicles in other domains is one for us to shape. I'd like to talk a little bit today about how we see some of those future markets and some of the strategic investments that we're making at Boeing. More broadly, some of the partnering opportunities across the industry and around the world. And I'd like to also bookend that discussion with the theme of safety. And I think it's very relevant to some of the ongoings, obviously, that have been going on at my company recently, and how safety is a critical element of everything we're going to do going forward. So with that framework in mind, what I'd like to do is move on to my first chart here around safety. And I think it's important to remember that as we think about unmanned vehicles and automation in the future, safety is our combined responsibility, a shared responsibility. And the recent Lion Air Flight 610 and Ethiopian Air 302 flights and those accidents weigh heavily on the Boeing company and all of our customers. And we're sorrowful for the lives that were lost, but I think it's also a really important reminder for us about the importance of safety in everything that we do. And that is something that we're committed to as a company and something that I think is important for our broader government and industry teams to always remember that lives depend on the work we do, that our responsibility as a company is to build the safest airplanes in the world, and that's a responsibility we take seriously and we own it. And that has to roll into how we do our work going forward. In this arena of aerospace safety, there's been a long legacy of partnership with the regulatory authorities. As you just heard, partnership, for example, with the FAA, between Boeing and FAA, stretches all the way back to 1927. And some of the teamwork around that in the 1997 timeframe, the Commercial Aviation Safety Team was stood up with a focus on safety. And since then, about a 95% reduction in fatal accidents in commercial aviation. Tremendous results that have occurred because of that partnership. And that collaboration going forward is really important to all of us. And the idea that we can exchange data, be transparent, look at trend information, that is all what has created the safest form of transportation in the world today. Last year, as you see on the chart here, 4.3 billion passengers on 46.1 million flights. Every day, 5.3 million people fly on Boeing airplanes. Every day there's about, or at any point in time, there's about 2,900 737s in the air with about 500,000 people on board. Every 1.5 seconds, a 737 takes off. So that all goes back to the importance of thinking about a system for the future that has a combination of both manned and unmanned aircraft, automation that can operate as a safe ecosystem. That continuous improvement cycle will be important. Recently, the stand-up of the unmanned aircraft safety team, using that previous model of the CAST team, will be really important to our future and an important part of collaborating and creating a safe ecosystem for unmanned aircraft. So through that lens, if we think about the portfolio of the future, just to give you a sense of some of the things that we're investing in, and I'd like to move even deeper into the topic of the future of mobility. These are some of the examples of aircraft and systems that we're working on at Boeing today that are being fielded. The 737 MAX that I already mentioned, the new 777X, which will be the largest twin-engine wide-body aircraft, most efficient aircraft ever, able to connect any two cities in the world in a single flight. This is going to revolutionize travel networks around the world, similar to what's happened with our 787 Dreamliner that since it was introduced has created 230 new city pairs around the world. This new 777X will go into flight tests this year and enter service next year. On the space front, a lot of work going on, and I'll talk more deeply about low Earth orbit space advancements and how we see that as a viable commercial ecosystem going forward. We're fielding the CST-100 Starliner. We'll go into first flight, first launch of that vehicle this year. Longer term, we're also building with NASA the first rocket to Mars. You see that in the upper left corner here, the Space Launch System. We believe that will be the rocket that will help put the first footprints, human footprints, on Mars. So some exciting investments that are going on right now, and some of the technology that's going into unmanned aircraft, the digital technologies, autonomy, artificial intelligence, is also revolutionizing how we design and build. And you can see that in our factory systems and robotics, and how robotic systems and human systems are working together on things like manufacturing lines in our factories today. So an exciting future ahead of us, both in terms of new products and services, as well as how we design and build. Now, given all of the advancements and benefits that have occurred as automation and autonomous systems have come into the world, there's one area that has not been relieved yet, and that is this area of urban travel and congestion. And all of you that are spending time in dense urban environments, sitting in traffic jams, you're experiencing this. Average one-way commute times that you see here, just to give you an example of some of the pain points in that future market, these are average one-way commute times. In the US metro area, the city with the longest one-way commute times, Washington, D.C., for those of you that are here from Washington, D.C. today, 43.6 minutes one way. Around the world, more than 25% of the average commute times are more than 90 minutes one way. This congestion is getting worse. It's getting more difficult. It's environmentally challenging as well because of the emissions. And what we see as a future that as this congestion continues to grow, the market forces will move us from two-dimensional traffic in urban environments to three-dimensional highways, flying taxis. And that future is not far away. So I'm going to talk about some of the investments we're making in that area as part of the future of mobility. But this is just one of the market forces that will drive innovation forward and I think accelerate the timeline for implementing unmanned vehicles. Now, if you think about more broadly that future of mobility, it's not just about vehicles. It's about services. It's about an ecosystem that enables economic value. And I liken this to the introduction of the jet aircraft. You see the venerable Boeing 707 in the upper left corner. When that airplane was introduced, it wasn't just about putting jet aircraft into commercial use. It was about the ecosystem that enabled it. Airport infrastructure, hotels, rental car infrastructure, retail infrastructure to enable travelers. So think about an end-to-end experience, an enabling ecosystem. We will need a similar enabling ecosystem for the future of mobility. And that will include safe infrastructure, the ability to fly commingled piloted and unpiloted vehicles, for example. We see areas of opportunity there around creating a secure airspace. And I'll talk a little bit about some of the work we're doing there. The idea of moving goods and products rapidly in dense environments, moving them by air. Opportunities to move people more rapidly, some cases in urban environment, some cases in supersonic and hypersonic and even space-based travel. And then finally, a low Earth orbit space ecosystem. These are all viable areas for future growth and places where we're making investment. I'd like to walk through that in a little more detail, but think about this future of mobility as one that will be system of systems in nature. It's one that will be multimodal. It will be on demand, and it will have shared assets. This is a new kind of ecosystem for the future of mobility. Let me walk into 4 areas where we see significant applications and work that's already well underway. First of all, defense systems. Very familiar to most of you in the audience here, but this is continuing to move at a very rapid pace. We have several unmanned systems that are in service with customers today, as do many companies. Among those things like the Scan Eagle that you see pictured in the middle of the chart. We see these unmanned defense systems moving into other domains. Many companies, including Boeing, are now working on underwater vehicles. You see the Wave Glider up at the roughly 2 o'clock position. This is a surface sensor vehicle that's powered by the waves of the ocean. So it's an autonomous capability that's self-powered. Echo Voyager is a large unmanned underwater vehicle. We just received a contract from the U.S. Navy to build the first 5 of those. This is about a 60, 70-foot long, large class underwater vehicle, multi-mission capability. This realm is also expanding into the domain of space, unmanned space vehicles. You see 2 pictured there on the left. Phantom Express is a new launch capability with the idea of breaking the launch cost barrier, the idea of being able to do 10 flights in 10 days, rapid insertion of satellites and other capabilities into orbit. And the X-37B, which has been our experimental space plane that has the ability to stay up in space for hundreds of days and autonomously re-enter the atmosphere, Mach 25 S-curves on the way down and hit the center line of the runway every time. It has broken a number of space-based endurance records. And we're also working with the U.S. Navy on the MQ-25 Stingray, which you see pictured in the lower right corner. I'll talk a little bit more about that on a subsequent chart. But significant advancements being made in that arena. The MQ-25 is a drone refueling aircraft. It'll operate off of aircraft carriers, catapult launch. It'll set up a rendezvous point where fighters will be able to tank autonomously off of that airplane. And upon completion of the mission, it'll return to the aircraft carrier and trap on board the aircraft carrier, all with autonomous technology. First flight of that airplane is this year, just to give you a sense of the pace that this technology is moving at. In addition to defense systems, we see opportunities for autonomous urban mobility. A couple of examples here of vehicles that are in flight today. You'll see a couple of videos pop up on the screen here. On the left side, our passenger air vehicle being built by our subsidiary Aurora Flight Sciences. Significant advancements here. This is a 2-person autonomous taxi vehicle. So as I mentioned earlier, this idea of 2-dimensional ground traffic rising up to become 3-dimensional highways. This is a prototype vehicle that we're flying, developing today, gaining confidence in its ability to operate safely. We expect to begin to see revenue operations of these kind of vehicles in the early 2020s, just around the corner. That'll start out on dedicated, safe routes. Think of it as tunnels in space, tunnels through the air. But more broadly, these will eventually turn into 3-dimensional highway vehicles. On the right side, you see our cargo air vehicle. This is a large-scale cargo delivery airplane capable of carrying about 500 pounds of cargo over significant distances. We're, again, flight testing this vehicle now. We see an opportunity, again, to rise up, take advantage of the air, and to be able to move cargo and goods much more rapidly, not just small packages, but large packages, things that are measured in hundreds of pounds, things that also can assist with manufacturing efficiency by moving products between factories, for example. So some exciting advancements on this front and vehicles that will go into service just over the next couple of years. A third area of high interest is supersonic and hypersonic travel. And this will, again, revolutionize mobility in the future. We've recently announced a partnership with Ariane, working on that AS-2 aircraft that you see on the left-hand side. It's a Mach 1.4 jet. We think it has the technology and the capability to make supersonic travel economically viable. This will cut transatlantic travel times by about 3 hours, and we think there is a strong business case for this airplane. A little farther down, we see an opportunity for hypersonic vehicles. These will eventually be both piloted and unpiloted vehicles. We're working on that technology today, airplanes that can fly at about Mach 5 to 6. Think about the ability to connect between any 2 points in the world in about 2 hours, and what that could enable economically and how that will change future mobility networks. Again, that's technology that we're actually flight testing today in terms of the engine technologies, and we expect to have viable configurations in flight tests over the next 5 years or so. And then fourthly, an area of interest is the space ecosystem. And again, there There are both piloted and unpiloted vehicles that'll play in this ecosystem. We see low Earth orbit evolving from what is today a largely government-funded effort to a commercially viable ecosystem for the future. Today, if you go to low Earth orbit, there's principally one destination, the International Space Station. And we work with NASA to maintain operations of that space station. And as you know, there are several companies, including Boeing and other competitors, who are working on vehicles to provide both cargo and crew transport to the space station. The vehicle that we're working on is the CST-100 Starliner. Again, first flight happening this year. Now that Starliner is designed to carry 5 people. As currently configured, it'll carry 4 astronauts on flights to the International Space Station. That 5th seat will actually be a commercially available seat. And we're going to use that to begin building out this commercial business model. We think over time there will be additional destinations in space. We anticipate space-based factories taking advantage of microgravity environments which create great opportunities in additive manufacturing, for example. Things like growing organ tissue can be done very effectively in space. We think those are viable opportunities for the future. Space tourism is another area that will grow. And as you get a critical mass of destinations in space, we'll also generate a space-based transportation system. And that's an exciting future. And we think that low Earth orbit ecosystem will evolve rapidly over the next decade, and it will need to be integrated across domains. So this idea of air and space integrated traffic management, for example, I think is another important ecosystem question for all of us. So I'll give you a sense of just 4 areas where we see future market opportunities, economically viable investments that are being made, technology-driven, but also driven by the framework for operations, the ecosystem that surrounds the technology. So to that point, again, I'll go back to where I started on safety and the importance of safety. Each one of these domains that I talked about will only be successful when it's safe, and it needs to be as safe as it is to fly by air today. That will include public adoption, so that's not only safety, but the perception of safety. You think about things like flying taxis. How many of you would be willing to get on an autonomous taxi with no pilot? Get on in your driveway, fly downtown, jump off, just like you might ask for an Uber driver to show up, you might ask for a Uber flying taxi to show up. Think about a future where you have that kind of on-demand shared capability to fly. Public adoption of that will be one of the hurdles to overcome. Regulation and safety. This is the wraparound framework, the enablers, the air traffic management systems. These are things that we're working on with the regulatory authorities today. Really important investment for the future. And ultimately getting to full aerospace integration, not just an airspace that will accommodate unmanned vehicles, but an airspace that's designed for unmanned vehicles and the coexistence of piloted and unmanned vehicles. Along those lines, we've recently established a joint venture with a company called SkyGrid, with Spark Cognition on a system called SkyGrid that is intended to be this future infrastructure. Think of this as artificial intelligence and blockchain technology applied to full airspace integration to make it reliable, operational, and safe. This is an important investment for the future. So something where Boeing is making a significant strategic investment, combined in this case with Spark Cognition. All of that leads us then to just a couple of key takeaways as we think about this future of mobility. This is an exciting time of innovation, but it has to start with this continuous focus on safety and remembering the importance of what we do. That needs to be fundamental in every step forward. We need to focus on value-added innovation, not just innovation for the sake of technology, but technology that can add economic value. Partnering where it counts. Companies like Boeing can bring a lot of capacity and resource to bear, but small companies, innovative, leading-edge companies, other industrial partners, government, and their important role. This is a partnership model for the future. And we all need to take this system view. It's more than the vehicles, it's the integrated ecosystem that will enable this safe future of mobility. So with that, I'll wrap up. But I want you to leave you today with this idea of the future of mobility is now. When you think about the innovation that's happening around us today, it's more innovation, again, than I've ever seen in the aerospace industry and in these broader domains that are introducing unmanned vehicles. This connects directly with our mission at Boeing to connect, protect, explore, and inspire the world through aerospace innovation. But it's also based on this foundation, the fundamentals around safety, quality, integrity in everything that we do. We have to remember that lives literally depend on the work that we're doing. That demands this utmost excellence in how we do it. So with that, we look forward to this future of mobility and look forward to working with all of you, working together to make that future a reality. Thank you.